Thanks a lot, Nikki. And so I'm here to do the light, fluffy, meaningless opening bit that basically introduces the topic and has no content whatsoever, and that'll be reasonably clear quite quickly. So I'm going to talk a bit about what decision science is, and I suppose I'm hopefully just going to annoy some people as much as possible. And that doesn't work. Oh, it does work. And as always, I should point out that, as Nikki's already pointed out, this is a group work. We've been thinking about assisted colonisation for quite a while and using decision science to put this into perspective. And I suppose one of the messages is, even though we've been thinking about it for a long time and we've done a lot of thinking and research and decision tools for it, it seems as though we're actually a fair way off doing anything for it, particularly for animals. Plants is easy, animals is different, and I think we should make sure we distinguish between the two, just because from a legal perspective they're extremely different. So a lot of people helped. That's roughly what I'm going to cover. I'm going to start back with a paper that we did in Science that Ove Hock-Guldberg led about and produced a decision tree on what we should do about assisted colonisation. But I'm going to really focus on these things: actions, laws, objectives and change. And I'm going to point out that actually, ignoring climate change entirely, we should have been thinking more about assisted colonisation for a whole heap of other reasons. In fact, maybe climate change is the least reason to think about assisted colonisation. There's plenty of other reasons why you want to stick a species in a place where it never was. And so we should have sorted this out a long time ago, and it's a bit depressing how slow we are. So let's talk quickly about what is decision science. Most of this conference is not about decision science. Decision science takes what 90% of the talks have been on, the science, is what happens when the climate change, where do we think a species will go? And that's where it ends. And then we say at the end of that, oh, this should be important for management and policy, but we don't say how. Decision science puts all the stuff around that science to make it actually happen in terms of policy and management. But it's not just us sitting around smoking a pipe and having a chat and deciding this is going to happen. It's actually a formal process. Many of you will know about it. It's been going on for a long time. Decision science runs the airline system, it runs the banking system, it runs manufacturing. Decision science runs the planet. It doesn't run much of conservation science for some reason. I don't know why. And that is what decision science is. This is sort of the USGS, who are a bit of the masters of this, and people like Jim Nichols and Mike Runge, Sarah Converse have been doing these things for a long time, helping them make decisions about how to manage ducks. And they teach it and they train it, and this drives a lot of the more rigorous wildlife management science that happens in the United States. And they would show a diagram like this when they were studying their decision science course, which would last 3 days. I've got 3 minutes. This is what it is. And you'll notice this is the bit, you think of a problem, what are we trying to achieve? That usually takes about 10 years, and then we think of all the actions we can take. And then there's a bit of science here, some data. I think some of you collect data, and some of you make a model, and you work out what those actions will mean in terms of outcomes, and then you do some trade-offs, optimisation, and actually do some decision. So these are 3 of the 13 boxes. 90% of this conference is about 3 of the 13 boxes. Okay. So the science is always a small part of the entire process. This has people in it, it has politics in it, it has legal issues in it, it has social values in it, social sciences as well. So we want to get this right, of course, but what this session is a fair bit about is actually some of the other packaging around that process. If this was talking not about management but about laws, then I'd put more about people, then I have to put lawyers in there, and then of course it's a mess. Okay, so we've been thinking about this for a long time. People talked about assisted colonisation probably before I was born. This was an attempt a fair while ago by Ove when he gathered a few of us together, and I know Camille's here, to just sort of, okay, when should we really be doing it? Because as soon as you talk about moving a species outside a normal range, an Australian just sees a cane toad and says, you're a moron, don't do it. We're not going to have polar bears in the Antarctic. So what do you got to think about? So you start going through this process, and this is what I call an example of a decision tree. It's a decision science tool to help a policymaker or manager roughly think about the things they've got to worry about and rule out some options. But it's a highly qualitative decision tree. So, is this thing that we're worried about, this is all about stopping something going extinct because the conditions are changing. Could be climate change, could be something else. Could it work? If it could work, and I move it somewhere, is that benefit of saving that species and associated species worth the pain that it could cause it because it goes out of control and wipes something else out? What if it doesn't work? Well, what am I going to do? Maybe if the risks are low, maybe I shouldn't be moving it. Maybe I should just improve connectivity and maybe we'll hope that it moves to where it needs to get to anyway. So this is sort of I think it raises probably 90% of the issues that have been raised generally in the literature, and each of those could be underpinned by a whole population model or a climate change model or whatever. And not too much recognition, some recognition of cost and feasibility in this decision tree, but also quite qualitative. Since then, there's been quite a few papers in this space, and I'm not going to try and review them all because I'm too lazy. This is an example of, again, using a decision science tool to ask one particular question, done by Eve, one particular question about if we really think something's going down. This is a model of, say, the carrying capacity of golden bowerbirds in the wet tropics, and this is the carrying capacity of golden bowerbirds at Lamington, and we think they're going to disappear from the wet tropics. We think that Lamington will be a fine place for them to live. This is their population. When do we grab a few and send them there? Bearing in mind nobody may want us to do that. It's too controversial, but they're pretty birds, so we should keep golden bowerbirds. So when do we decide? And we move them, and then if you move them too late, there won't be any to move, or you won't have enough to move. If you move them too early, maybe they didn't need to move, and you're just causing a problem and a lot of costs that you didn't need to have. So this is an attempt to rationalise that and a more quantitative tool. Oh. Okay. So there's a lot of decision science out there, but I think actually we've still got some things we haven't really talked about, some maybe embarrassing things we haven't really talked about. People talk, I think Camille and others have talked a bit about we need to move all these species. Let's face it, we haven't really moved any, and there's thousands we'd have to move. And moving a species is probably going to cost you what? For an animal, $1 million, if not $2 million, and we know that it often doesn't work. How many, the federal government is not funding threatened species recovery. The states fund some threatened species recovery, NGOs. We don't have the money to move hardly anything at the moment. So we've really got to decide how many can we move. And we've also pointed out that even if you just move one species, those species live with other things. Should we be moving entire communities? How do you move an entire community? What do you do? Has anybody tried to move an entire ecological community? Last weekend? No. I mean, you could say, what about I go to Western Australia or somewhere where they're digging up at bauxite and Alcoa's got a whole heap of topsoil. Why don't we just take a hectare of topsoil and we'll move it 300 kilometres, see how that goes and see what happens. It'll move lots of things, won't it? I don't know how many thousands of species you move in a hectare of topsoil. Actually, the building industry do this quite a lot without telling us. But you could do that, and you could move an entire plant. You're not moving the animals generally, but you're not moving the large animals. You're moving the little animals. Have we ever tried that? Could we move? Maybe we could move entire communities moderately cheaply, thousands of species, to deal with potential changing climate. If you are going to move something, maybe we shouldn't take these golden bowerbirds and stick them in Lamington. Maybe we should just get them going in the zoo for a few years, see how they go, or put them on an island. Islands are nice places. They're not too hot, they're not too cold. They could sit there and then just wait and see how they really do go in the wet tropics and whether they are disappearing off the top of the mountain, which I'm somewhat sceptical about. Wait for that, and if they do, then we say, okay, we'll move them, but let's not move them until we're sure that they are disappearing. That sounds a good idea. That's sort of risk sensitive. That's extremely expensive as well. There are lots of, I don't think we've done enough work on working out whether things can move. Whether things will move. So, you know, the plant that grows best in my father's garden in Adelaide and seeds and reproduces is the Grevillea robusta, Adelaide, Grevillea robusta, 1,500 kilometres outside its distribution. It's a subtropical rainforest tree. It's growing in Adelaide, a Mediterranean climate, and it's breeding and seeding and covering the garden. So do we even know what we're doing about niche models? So some other interesting things is if we really don't know what we're doing and our SDMs actually aren't very good at predicting the future, bearing in mind actually other changes are probably affecting species more, like disease, invasions and habitat loss. Maybe if you took the E.O. Wilson view of the world, we should keep the parts of the clock, I think he said, if you want to reassemble. Maybe just grab a whole heap of things that we're worried about and put them everywhere, anywhere. Mountain pygmy possum used to live in subtropical rainforests. Let's send it to Wollongong. Don't worry about sending it to Tasmania. We'll send it to Wollongong, put it in a rainforest. Might go well. So, you know, maybe we should be starting to do more of the things that the plant people have actually done a long time ago when they were trying to experiment with niches. The forestry people take Pinus radiata, we'll put it in 1 hectare plots all over the country and see how it goes. Dangerous, but maybe something we should be trying and doing before we run out of time. But let me channel Richard now and channel actually the problem. Remember that decision science diagram at the top? It said have some objectives. Let's face it, we don't really even know what society wants. We don't even know what we want. We haven't made very clear decisions about how much we're willing to pay to keep biodiversity, how many risks we're willing to take. So until we can sort that out, we're not going to get very far. You know, I grew up putting plants in my garden where the seed had come from within 2 kilometres of my garden. Okay, I was obsessed with growing exactly what was there, forgetting that an emu could swallow a seed and poop it out, having gone 20 kilometres. So we, I think, have moved away from that obsessive nature, that we're going to reconstruct the world the way it was in 1750 or 15,000 BC, but we still haven't worked out how far we're willing to go into a brave new world where everything looks different, and how much we're willing to do to keep the species. Christmas island pipistrelle, rather than trying to grab them, spend several $1 million and putting them in a zoo, why didn't we grab the Christmas island pipistrelle and release it on another island? Why didn't we grab it and put it into the Kimberleys? I have no idea. Wasn't allowed, wasn't even thought of. The other options are very expensive. And I think we should embed some of our climate change work, acknowledging that climate change has wiped out far fewer species than almost the other major threats, and I still don't think it's the major threat to biodiversity. There's lots of other changes. Lots of other changes. Habitat lot changes, invasive species changes. If foxes get to Tasmania, that's probably going to have a bigger impact on biodiversity than if the climate changes. So you have plenty of reasons to do assisted colonisation to prepare for uncertain futures, diseases, pests, and just even changes in legislation and the way that habitat is managed and changed. So I think we should be thinking more. I know it's hard because a lot of the other changes in the world are fickle and unpredictable. They're technology changes, they're human value changes. We don't have clever models for them. We have clever models for climate change, but we need to do more change modelling, not climate change modelling per se. There's not a lot of change modelling going on in the world of ecology because it's hard. And then I just mindlessly advertise Decision Point. So this is our venue for making all our science readable to managers, and also in particular we can say silly things that I've just talked about and get away with it without having to go through peer review. Thank you very much.